Now we are discussing about inclusion and exclusion principle. The theorem, we will also write the statement of the theorem. Actually, this is a theorem as well as a principle. And what is this theorem or what is this principle? Inclusion, exclusion. So this is N of A union B. N of A union B, this can be written as N of A and plus N of B, and exclusion, what can be included and what can be included, it is N into of A intersection B. In case of union, you will exclude intersection, and similarly in case of intersection, you will include? You will include N of A and plus N of B. So what you will exclude? You will exclude N of A union B. Okay. N of in case of union, you will take intersection, and in case of intersection, you will exclude A union B. Okay. And the third case is N of A union P union C. What you will include? You will include N of A plus N of P and plus N of C, and you will exclude minus N of A intersection P minus N of A intersection C, A intersection C minus N of P intersection C, P intersection C plus N of A intersection P intersection C. Now we are talking about of course inclusion and exclusion principle. There are some other more results, just like if I will write A union A union A, if it is equal to A, or A intersection A intersection A, if this is equal to again A, then this is called a idempotent law. Idempotent law. Idempotent law. And the distributive law is very obvious. Okay, this is first, and in case of second, the distributive law. In case of distributive law, you can write A union P union C, P union C is equal to A union P, and this is C union C. And similarly in case of intersection, A intersection B intersection C, B intersection C is equal to A intersection B and intersection with C. This is actually a distributive law. And when we talk about identity element, the identity element will be just like as when we take the union of A with an element with empty, you will get A, and similarly the intersection of A with empty, if of course empty, okay, and or a union of A with the universal set is equal to universal set, or intersection of A with the universal set is equal to A. This is actually identity element or identity law. There are some other more laws of course discuss over here. The third is involution. The fourth is actually involutions. This is a double complement of any set will be equal to the set. This is called actually the involution. Okay, and now we are discussing about the complementation. Fifth is complementation law. This is A union A complement. A union A complement is equal to universal set. In the similar way, A intersection with A complement is equal to empty set. Similarly, U complement of universal set is empty, and a complement of empty set is equal to universal set. Finally, we are discussing about De Morgan law, which is very important in set theory or advanced analysis. So what is De Morgan law? Actually, it is A union B complement is equal to A complement intersection B complement. A intersection P complement is equal to A complement union P complement. Okay, so this is actually a De Morgan law. De Morgan law. So this is all about inclusion-exclusion principle.